Hello everybody, in this video I'm going to try to run object detection using TensorFlow Lite using the C API. So I have this blog post about doing object detection using TensorFlow Lite with a C++, and it was specifically for iOS, Android and iOS. And then when I wanted to run this object detection on Windows, I had to compile TensorFlow Lite C++ library on Windows, and the DLL was huge in size. And then someone from TensorFlow actually suggested that I will use the C DLL and not the C++. So this is what we are going to do, and let's start. So the first thing that we need is to actually compile and build the Windows C DLL. If you want to skip that part, you can you can go to one of my repositories. So I have a tflite dist distribution. So this is a repository that I'm trying to maintain until I won't have time to maintain it, but basically it contains libraries and headers for working with TensorFlow Lite in iOS, Android, and now Windows. So you can just download this zip file and extract it to your hard drive, and this is what it's going to look like. So it's going to be tflite dist. We have the include folder, which here we have all the header files that we need. Actually, we have all the TensorFlow headers here, so a lot more than what we really need, but it doesn't hurt. And under libs, there are going to be the C++ libraries for each platform. So for example, for Android we have the C++ shared object, and now we also have the C shared object and also the GPU delegate. So this is for the Android. For iOS we have only the C++ one, and for Windows we are going to have the TensorFlow Lite C DLL, which is only 1.4 megabyte, where compiling linking the C++ DLL was like 60 something megabytes. It was huge. Okay, so this is one option. Download this distribution from my repository, but we are going to try and build it just for the fun. So in order to build in TensorFlow, you need to download Bazel. So you can go to the GitHub of Bazel and their releases, and in order to know what version you need, so this is TensorFlow. So I just got it using git clone. So this is a fresh clone of TensorFlow, and if we are going to check the configure script and look for Bazel, we can see that the TensorFlow minimum Bazel version is 2.0 and the max Bazel version is 3.99, which bring me to this, that currently I don't want to work on a master because I don't know if TensorFlow master is stable. So we're going to switch to 2.2.0. so git checkout v2.2.0, and now we'll check again the required Bazel version. So yeah, 2.0. So I already this is the Bazel I already downloaded. Here under assets there is the Bazel window for 64 bits. So I got Bazel, I put it somewhere in my hard drive, and I made sure that it's in the path. So now when we open command prompt, and let's go to TensorFlow directory, and if I do where Bazel, I have it, and the version, it should be 2.0. okay, it's 2.0. So the next thing that we want in order to build, we need to run the configure script. So Python configure.py. It's gonna ask some questions, so I'm going to use this Python version, and this is the site packages. Okay, and the rest is basically I'm just taking the default, and this is the configure. And now we can go ahead and do the build. So I have here a cheat sheet of basically how the command should be. So it's Bazel build, and we are building the CDLL, and then I think it's just -c and optimize. Okay, now it's going to start the building. One thing that I noticed in the past, when building from command line, it requires a Git to be in the path, because it's going to clone some repositories. So you want to have Git in the command in your path, and it's going to take a while, so we'll be back. Okay, so I got an error, and it says that lib TensorFlow Lite C DLL, and there is no such target, which makes sense because I copied the command building for Android. So for Windows is just TensorFlow Lite C DLL. Let's see now. Okay, so it's continuing, and I let him do his thing. Okay, and it's done, and it tells us that the output is Bazel bin TensorFlow Lite C, TensorFlow Lite C DLL. So let's check it out. So it's Bazel bin TensorFlow Lite C, and here is the TensorFlow Lite C DLL, and we also have the lib. So this is the lib. So you will want to take these two files and save them somewhere. Besides the library and DLL, the headers of the C API are also necessary. So it's under TensorFlow Lite C, and there is the C API header file and the common.h header file. But as I mentioned before, I'm going to use the include and libraries for my tflite dist. Okay, so we are done with building TensorFlow Lite C DLL. The next thing that we are going to use, the next thing that we will use in our example is OpenCV. So in the OpenCV website, under releases, you can download the Windows release. This is just a self-extracting zip file, if I remember correctly. I will not download it. So just extract it someplace on your hard drive. I already did this. It's in C Tools OpenCV. What we care about here is under build, we have the include folder with all the header files, and under x64 Visual C 15 we have the bin folder with the OpenCV World DLL and the OpenCV World library. The one with D at the end is for debug. This is for release. So we will use this as well. And before we go to Visual Studio, still we have some more setup that I want to show. So I defined two global environment variables. One is OpenCV dir, which just points to the installation of OpenCV. I mean, this folder that we just saw. And another one is tflite dir, which points to this tflite disk with the include and lib. So I'm going to use this environment variables in Visual Studio, and we are not done. One more thing which is very important. I added to my path, I added this folder, the tflite disk libs Windows x86-64. So this one, in runtime, our program is going to look for the TensorFlow Lite C DLL, so it's important that it will be in the path. And I also did the same for OpenCV. So in runtime, it's going to look for the OpenCV world DLL, so I added it to the path as well. So that's that, and now we can go to Visual Studio, and let's start a new project. Creating a project. It's going to be console application, tflite C Windows, and we put it in the TMP folder. Great. So we're not going to write the object detection from scratch. We will use the native the object detector that I wrote for the cross-platform project. So we will use these two. But first, let's see that our project is building and running. So using name, I like this. And also I'm going to work on the release 64-bit. I read somewhere that the TensorFlow Lite on Windows doesn't work really well when we are on debug. I didn't test it. I don't know whether it's true or not, but I will just work on it in release. And our project compiles and run. Okay, so let's create a header file and object detector. So header, and let's already do throw the detector CPP, new item, CPP. Okay, so our header is this. And our implementation is this. We don't care this. Okay. Now we will go over the code, because we will need to fix some stuff, because this code, this object detector is using TensorFlow Lite C++ and not C. But first we need to set up our project, to set up the include folders and library and all that stuff. So properties under C++ general additional include directories. So you remember the environment variables that I set up. So OpenCV dir. So the OpenCV environment variable reference this folder. So under build include, this is what we want. like so. And we are going to do the same for the tflite dist include, just include. So it is tflite dist include. Slash include tflite, not dist, dir. Okay, so I can see here that they interpret the environment variable correctly. So this is the include folders. Apply, and we can see in the background that they include no errors on the include. But if we are here, we will also set up the libraries. So under linker, we have additional library directories. So again, we need the library for OpenCV and then TensorFlow. So it's OpenCV dir, and again, it's here. So we need this. And for TensorFlow, it's tflite dir /libs. What was it? So we need this. Okay, so we have the include libraries, and now we need to provide the libraries themselves. So it's input additional dependencies, and once again, this is TensorFlow 1, and for OpenCV, I know that it's OpenCV world lib, but I don't remember what was the version. For one. Okay, so now we are set up. So anywhere we have TensorFlow Lite, we don't want this because this is the C++. So we are going to do TensorFlow Lite C API. So we have the C API, and we can look at this header file. So they were nice enough to give us some starter code and how to load the model, create interpreter, and invoking the model. So we will use this code, and basically the types, the C++ types and the C types, are more or less the same name, besides the prefix that the C header has, which is a tflite. So if you go here, so instead of flat buffer model, it's just tflite model. It's a pointer to the model, and the interpreter also it's tflite interpreter. So it's a pointer to the interpreter, and the tflite tensors it's the same name, so we are good here. And this is our header file. So what we have for our object detector is we have a constructor where we get the model binary. Just we will read the tflite model, the binary file, and we'll provide it here. We'll provide the size and the boolean whether the model is quantized or not. And then we will have a detect method which will run detection on an OpenCV image, a matrix, and it will return an array of detection result. And this is the detection result, which is the label, the score, and the bounding box. So this is pretty much our object detector. Here we define some constant. What is the model size? So I know that I'm going to use a model which is the image is 320 pixels. So I'll change the model size here, and this is for normalizing the input, and that's it. Now let's fix the implementation. So again, we don't want anything with TensorFlow Lite C++. So I'll remove that, and let's see the errors. So first thing we need in our constructor, so we get the binary file from the user. So the first thing, we are copying the model to our object, so we will be owning the model file, and then we want to build the model. So in their example, creating the model, there is tflite model create from file. Okay, but we are going to create it from buffer. So let's see, tflite model. Okay, so there is tflite model create, which gets byte array and size. So I believe this is like built from buffer. So we'll take this, copy here, and then we'll check if the model was created. And now we want to build the interpreter. So we'll take this example, create the interpreter. It starts from here. So interpreter options, and then the interpreter. We'll copy, and we'll see if we need, what are the adjustments that we need. So number of thread, I will use 1, and then creating the interpreter is like so, and the model, this is m_model in our case, and this is our interpreter, m_interpreter. So we create the interpreter, then we can check if it was created successfully. Okay, next, we want to allocate tensors. So tflite interpreter allocate tensors, and the parameter is the interpreter. So this is this. Set number of thread we already did. Getting the input, the model input. So input tensor, tflite interpreter get input tensor. Okay, but okay, what we do here is we verify the model that we got, so that we have one input, some sanity check for the model. So let's see, tflite interpreter get input tensor count. So it's this. So we check the number of input tensors, and then we take the tensor. So it was tflite interpreter get input tensor. Get input tensor index. We take the first one, and then we check the type of the model. If the model is quantized, it needs to be unsigned int. If the model is not quantized, it should be float 32. And Then we check the dimensions of the input tensor, which should match our detection model size, which is 320 pixels. So there is also sanity check on this one. And then we are checking the output tensor. So in our model, we expect to have exactly 4 output tensors. So tflite interpreter get output tensor count. And then we want to get a reference to all 4 tensors. So tflite interpreter get output tensor interpreter and index, I believe. And 1. Okay, what's the problem? A value of type const tflite tensor cannot be assigned to tflite tensor. So let's change the definition. Const. Okay, so we finished our initialized method where we load the model, create interpreter, check the input tensor, output tensor, and get reference to the input and output tensor. The next thing is running the actual detection. So here I know that I have a bug in the code that I in my repository. So the result should be an array like so, and yeah, obviously. Okay, so we define the array, and then we take the input image, we resize the input image to the model size. And also here I know that I forgot to check, so checking the image type, if it's grayscale, if it's 4 channels, RGBA, and need to check if it's RGB. So if it's 3 channels, we are going to convert from BGR to RGB. So basically OpenCV, when reading images from OpenCV, the format is BGR, and our model expect the image to be RGB. So this is what we do here. We just convert. If it's grayscale, we convert from gray to RGB. If it is 3 channels, convert from BGR to RGB, and if it's 4 channels, BGRA to RGB. So we convert. So we make sure the format matches what our model expects. Then if the model is quantized, what we do, we take the input tensor data as unsigned int 8-bit. We take a reference to this memory chunk, and then we just copy our image data into the tensor memory. So this is a simple mem copy. If the model is not quantized, we need to convert the image, the OpenCV image, to float and normalize the data. So this is what we do here. OpenCV images by default is 8-bit unsigned int. So we converted to a 32-bit floating point, and then we do the adjustment. We divide each pixel by the standard, what we defined as the standard deviation, and we subtract the mean divided by the standard deviation. Basically, this is the transform that we are doing. We are normalizing by the mean and standard deviation. And after we did this conversion, we just like for the quantized model, we copy the image data into the input tensor. Note that here we are referencing the data as float. Here we reference the data as uint, unsigned int. Here we reference the data as float, and then we just do the copy. Finally, we need to invoke the interpreter. So let's check in the example. It's tflite interpreter invoke. So we check that the invoke was successful, and then we handle the results. So this code is the same. Basically, we take the detection location, detection classes, detection scores, and number of detections. So this is the 4 output tensors that we have in the model. We loop through the results. Note that our detector limits the number of returned detections to 3 here. So we make sure that we loop to all the way to num of detections, but we are not beyond the detection num that we are limiting. This is just a number, no special reason why I choose 3. I know that the model that I'm going to use will give 10 results, 10 detections. And then we just take the score, take the label, and we are building the bounding box. What's important to note here is that the bounding box that the model returns are between 0 to 1, that they are normalized. So we are going to multiply it by the input image dimension, rows and calls, height and width. So the bounding box that we are going to return will be already coordinates in the image coordinate space and not normalize the locations. And let's try to build the solution and see if we did right. Okay, so we built it. Looks like we are good. So now we just need to get a model, load image, and run inference, run the detection. Okay, so here I know that I'm going to need OpenCV core and include OpenCV high GUI for reading images. So this is for now, and using name space CV. So let's start with image. On splash.com, let's look for image of orange, banana, apple. Okay, so credit where credit is due to Jack Carter, and we are going to save the image to our project, and we'll call it test JPEG. Now let's try to read the file. Source im read test JPEG, and let's display the image, and we need to wait in order to see something. So we're going to wait until hit any key. Let's run. Okay, so we got the image. Good. Now we need a model. So I have a blog post how to convert models to TensorFlow Lite, and there is a section on converting SSD object detection. So you can do it yourself. I know that I have in my project tflite models. I have a model here. Now for this SSD object detection, the quantized model is not working good. I'm not sure why, so I will we'll just take the floating point model. I'll copy the model to our project here. And now we need to read this file. So read binary file C++. Okay. Visual Studio. And needs include f-string. Okay, so our model is model float tflite. Let's see. Yes, model float tflite. We are reading the file, and we don't care about writing the file. So buffer is going to be the binary array of the model, and length is the size of the model. And let's include our object detector, and object detector. Let's create an instance. So it should get the model, which is buffer in our case, and the size is length, and it is not quantized. And detect result is detector.detect, and we'll give it the input image. Okay, basically that's it. Now let's loop over the results. So we know that we are expecting 3 results. I think under detector we have this detect num. So let's grab all the model results. So we have the label, which is label. Then we have a score. Our label is actually integer. The score is float. And then we have the bounding box. So I'm doing it just for sake of convenience. Of course, you don't need to destruct the result object. And ymax, ymin, and ymax. Okay, and let's print it. Just the label and let's go. We don't care about the bounding box. Okay. Don't care about this, don't care about this. Let's see if we get something. Okay, so we got label 52 and the score, and then no label, just score. Okay, let's do this. Print a new line. Okay, so we got 3 labels and score. Now let's visualize it. So the model is running. We didn't get any error. We don't know if we got correct results. What we can do is we can draw the bounding box on our image. So in OpenCV, to draw a rectangle, there is a rectangle method, which is under image processing, I believe. Rectangle. Okay, so our image is SLC. We need to provide 2 points. So x min, y min, and another point is x max, y max. And the color is a scalar. Now remember, OpenCV is BGR, and I want to do a red rectangle, so it's BGR, thickness 2. So let's put text. So let's draw the label. So again, we're doing it on our image, the string to string label. Point, we'll use the top left corner. Font, I think it's font Hershey. Let's do plain. Don't know what's the difference between all the fonts. Font scale, let's do 1.5. That's sort of font size, I guess. And color and thickness, we'll do like the bounding box. We don't need this. We want to show the image and we want to wait. Let's see. Okay, so we got objects, correct objects that are detected. Now we need to see what's the label means. So I have here the label map of the SSD object detection, and basically this number, this label, is the class ID. So in the model result, the background class doesn't count, so I'll just remove it. And this class ID is it's a zero-based index. So if you want to see what is number 52, it's zero-based, so we'll go to line, we are counting from 1, so we'll go to line 53, which is apple. And 54 will go to line 55, which is orange, so that was correct as well. And this pineapple, 55, so line 56, broccoli. Okay, so I don't think there is pineapple in this model. It's trained on the Coco dataset. Yeah, so no pineapple. It confused the pineapple with broccoli, but it's nice, it's working. Let's try to do, instead of 3 detection, 5 detections. Let's see if it will get the banana. Okay, so we got more apple, so now the green apple is detected as well, and the orange, this is broccoli, still the same mistake, and we have the banana as label 51, so it's going to be line 52, which is banana. Great. It's cool. Okay, so let's see if we are at it. Let's add the scores here. We'll do like so, to string of the score. So score is like certainty of the classification. Okay, so that's why the bananas came only when we raised the detections to 5. It's 0.48, so like 50% certainty. This apple and orange, which we got first, are 0.6, 0.68. The fake broccoli is 0.66 and this apple is 0.6 as well. So it's not very high scores, but it's working, and it's besides the pineapple, which is not in the data set, so it confused it with something else. It's working nice. So great. This is how we do object detection using TensorFlow Lite and the C API. I hope you find it useful. It was fun. Thank you. Bye bye.